At night, your chances of surviving a tornado drop by more than half. Statistically, these storms are 2.5 times deadlier in the dark than in daylight. We all picture that classic funnel churning across open fields in broad daylight, terrifying yet visible, giving you a chance to run or hide. But what happens when you take away the light? When rain hides the monster, or a storm moves in after midnight while you sleep, danger becomes harder to detect. There is a reason tornado deaths are shifting into the shadows, and understanding why could mean the difference between escaping disaster and never seeing it coming. So why do tornadoes become so much more lethal the darker it gets? During daylight, the threat of a tornado feels real but manageable. The human brain is wired to trust what it can see. Almost 90% of our perception of danger depends on vision. When a funnel cloud forms in the distance, stretching from the base of a thunderstorm to the ground, there is a moment of clarity. The shape is unmistakable. The color stands out against the sky. Even in the chaos of a storm, the mind registers the warning: move, take shelter, act now. This reliance on sight is not just instinct, it is survival. People scan the horizon, searching for contrast, movement, or the telltale swirl of debris. Parents gather their children. Neighbors shout warnings across yards. Sirens wail. But it is the visual confirmation, a dark, twisting column, that makes the danger undeniable. In daylight, even the most violent tornado is, in a sense, honest. It gives you a fighting chance. Storm chasers, the veterans who spend their lives tracking these monsters, understand the power of seeing the threat. One chaser put it simply, if you can see it, you can survive it. For them, the open fields and wide skies of tornado country offer a kind of uneasy reassurance. They know where to look, how to read the clouds, and when to move. Even the most intense storm becomes a puzzle to solve, not a riddle lurking in the shadows. The psychology behind this is clear. Visual cues trigger the body's fight or flight response. When you see the tornado, adrenaline surges, muscles tense, and every sense sharpens. People take shelter faster, make better decisions, and are more likely to survive. Warning systems and weather apps help, but nothing matches the urgency that comes from seeing the threat with your own eyes. This sense of control is fragile. It depends on the ability to spot the danger before it is too late. In the open, with a clear view, the odds are in your favor. But as the sky darkens, or as the storm grows more complex, that certainty begins to slip away. The visible tornado is only one version of the threat, the one that lets you see it coming. The comfort of daylight, the logic of vision, and the confidence to act all rest on a single crucial fact. When you can see the danger, you can do something about it. That certainty is about to vanish. Sometimes even daylight can't save you. In the world of tornadoes, there is a kind of storm that turns the rules of survival inside out, the high-precipitation supercell. On radar, these storms look bloated and dense, a mass of swirling rain and hail, wrapped tight around a hidden core. On the ground, they are a moving wall of water, blotting out everything behind them. The tornado is still there, but it is buried, cloaked by a curtain so thick that even the most alert eyes see only rain. Scientists call this precipitation wrapping. As the storm's rear flank downdraft surges, cold air and torrents of rain spiral around the updraft, swallowing the tornado whole. The classic photogenic funnel disappears. In its place, a gray-green void. There is no silhouette, no warning swirl, just the hiss of rain and the distant rumble of thunder. For anyone in the path, the danger is now invisible. Radar, the trusted guardian of storm spotters and meteorologists, struggles too. In high-precipitation supercells, the familiar hook echo, the telltale radar signature of a tornado, gets smeared and blurred by sheets of precipitation. The kidney bean shape replaces the classic hook. Velocity scans, meant to pick up rotation, can be muddied by rain and hail, masking the tight couplets that signal a tornado's birth. Even dual polarization radar, designed to spot debris, can miss the moment a tornado touches down if the debris ball gets lost in the noise of heavy rain. Radar can be fooled. Lead times shrink. Instead of the 10 or 15-minute warning that saves lives in classic storms, people in the path of a high-precipitation supercell might get only a few minutes, sometimes none at all. The tornado is there, but by the time it is confirmed, it is already on top of you. The El Reno tornado of May 31st, 2013, stands as a grim warning. That afternoon, a monster storm rolled across central Oklahoma. Chasers and researchers, some of the best in the world, were tracking it. But the tornado that formed inside the rain core was nearly impossible to see. It grew to 2.6 miles wide, the largest ever recorded, but its true shape was hidden until it was too late. 4 experienced storm researchers lost their lives, caught off guard by a tornado they could not see. Even with all their training and technology, high-precipitation supercells do not wait for nightfall to turn deadly. They create their own darkness, erasing the visual cues that people depend on. The sense of safety that comes with daylight is an illusion. When the rain wraps tight, the tornado could be a mile away or 100 yards. You will not know until the wind is at your door. The comfort of sight is gone, replaced by uncertainty and the uneasy feeling that something monstrous is moving just out of view. Above the quiet fields and sleeping towns, something stirs after sunset. While the ground cools and the air settles, a hidden river of wind begins to flow a few thousand feet overhead. Meteorologists call it the Nocturnal Low-Level Jet, between 800 and 2,000 meters above the ground, invisible to the eye but powerful enough to shape the fate of entire regions. It is not a gentle breeze. The jet can surge at speeds over 20 meters per second, drawing warm, humid air northward from the Gulf of Mexico. This stream of energy is strongest when the world below is darkest, usually peaking between midnight and the early morning hours. The formation of the low-level jet is a product of nighttime physics. As the sun sets, the ground cools rapidly, creating a stable layer of air near the surface. Turbulence drops off, and the friction that slows daytime winds all but disappears. Above this quiet layer, the atmosphere is still restless. The pressure gradient, the difference between high and low pressure systems, remains, and without surface drag, the wind accelerates. This is the Blackadar inertial oscillation in action, a nighttime engine that spins up a swift, focused stream of air just above the sleeping landscape. This jet is more than a meteorological curiosity. It acts as a conveyor belt, transporting moisture and instability deep into the heartland. As the jet intensifies, it funnels warm, saturated air into waiting storms, feeding their updrafts and helping them survive long after sunset. The result is a nocturnal environment primed for severe weather. In the Southeast and Ohio Valley, where the jet's influence is strongest, the risk is amplified. Here, the overlap of rich moisture, strong wind shear, and persistent instability sets the stage for tornadoes that can last for hours, often striking well past midnight. The low-level jet does not just supply fuel, it also sharpens the wind shear, the change in wind speed and direction with height that tornado-producing storms need to organize and rotate. With the jet roaring overhead, the difference between surface winds and those aloft becomes dramatic. This vertical wind shear is essential for supercells, the parent storms of the most violent tornadoes. When the jet is at its peak, storms that would normally fade after dark grow stronger instead, sometimes reaching their most dangerous phase when most people are least prepared. Field campaigns like Vortex 2 have measured these jets in action, launching weather balloons and using wind profilers to capture their strength and timing. The data show a clear pattern. Major nighttime tornado outbreaks almost always coincide with a robust low-level jet. During April 27, 2011, for example, the jet's core pumped moisture and energy into the region all night, allowing supercells to persist and spawn tornado after tornado across the Southeast. This hidden engine is relentless. It operates out of sight, above the reach of headlights or porch lights, and far beyond the senses of those on the ground. Radiosondes and remote sensors confirm its presence, but to those below, its power is felt only when storms refuse to die, or when a tornado appears in the darkness with no warning at all. The low-level jet is the silent architect of the nocturnal threat, a force that keeps the atmosphere restless while the world sleeps. Night falls, and the world shrinks to the reach of a porch light or the glow of a bedroom clock. For most people, darkness means rest, a time to let down their guard. But in tornado country, the night brings a different kind of threat, one that feeds on the limits of human senses. The tornado's howl becomes the only warning, and the line between safety and disaster blurs with every passing minute. Nearly 40% of all tornado fatalities now happen after sunset. That number is not an accident. It is a reflection of how the human body betrays itself in the dark. As sleep takes hold, reaction times slow. The mind drifts and the instinct to act fades. Tornadoes that strike at night do not just catch people unaware. They catch them defenseless, lost in dreams, or trapped in the quiet routines of evening. In rural towns and city neighborhoods alike, sirens may sound, but many never hear them. Phones vibrate on silent. radios are turned off. By the time the wind rises, it is often too late to run. Survivors of night tornadoes speak of a terror that is almost primal. There is no shape to fear, only sound. The approach of a tornado in the dark is not a sight, but a feeling. A sudden, suffocating pressure, the rattle of windows, the low, growing roar that builds until it shakes the bones. Some call it the sound of a freight train barreling through the night, unstoppable and merciless. Others remember the flashes, lightning strobing across the sky, or the blue-green burst of power lines torn apart, each one a split-second glimpse of chaos. But the tornado itself remains invisible, a monster defined by the destruction it leaves behind. In the chaos, hesitation is deadly. People wait for proof, a glimpse of swirling debris, or a dark funnel against the horizon. But darkness offers no confirmation. The urge to see before acting becomes a trap. Studies show that most tornado deaths at night happen indoors, often to people who never made it out of bed. The warning comes, but the eyes search for something that is not there. Seconds pass. The storm arrives. Walls collapse. Meteorologists feel the weight of this helplessness. National Weather Service forecasters describe the agony of watching a tornado on radar at 2 a.m, issuing warnings they know may never wake the families in its path. One forecaster from Paducah, Kentucky put it bluntly, "There is no lonelier feeling than watching a monster on the screen, knowing most people are blind to it." Even the bravest storm chasers hesitate when night falls. The veterans, those who have faced down the largest tornadoes in daylight, often refuse to chase after dark. If the people who hunt storms for a living fear the night, what chance does an ordinary person have? The statistics are clear, but numbers alone cannot capture the dread of those moments. The real danger is not just the wind or the debris, but the silence before the storm, the absence of sight, and the trust placed in warnings that may never reach sleeping ears. In the dark, survival depends on reacting to the unseen, a test of faith in science and the instincts that remain when vision fails. Radar is the backbone of modern tornado detection, but even the most advanced systems have blind spots. The WSR-88D network, a lattice of Doppler radars across the United States, scans the sky in sweeping arcs. Its lowest beam, set at just half a degree above the horizon, is designed to catch rotation near the ground. But at a distance 75 miles from the radar site, that beam is already more than 2,000 feet above the Earth. Anything happening below that altitude, including the first moments of a tornado's formation, can slip beneath the radar's gaze. This is not a rare problem. In much of the rural Southeast and Midwest, entire counties sit in these radar shadows. Tornadoes that spin up quickly or stay close to the ground may never register on the screens of forecasters until they are fully developed, or until debris is lofted high enough to be detected. The geometry is unforgiving. The farther the storm, the higher the beam overshoots. In some places, the lowest scan might be sampling the sky 3,000 feet up, well above the level where most tornadoes do their worst. Lead times shrink as a result, Instead of the vital 10-minute warning that can save a family, people in these blind zones might get only a few minutes notice or none at all. The warning system, trusted and relied upon, is not infallible. When darkness falls and eyes are useless, these technological gaps become more than a technicality. They become a matter of life and death. The invisible monster can rage beneath the radar, hidden from both meteorologists and the public, until it is already too late. Mayfield, Kentucky, December 10th, 2021. The tornado sirens sounded just after 9 in the evening, but for the workers inside the Mayfield Consumer Products candle factory, the warnings felt distant, almost unreal. The building was packed, the hum of machines blending with the wind outside. A few people checked their phones. Some hesitated near the exits, but supervisors insisted everyone stay put. Outside, the sky was black, and the air pressed heavy against the windows. Moments later, the power failed. Darkness swallowed the factory floor. Someone shouted. Then the noise became a roar, deeper and louder than any storm before. The walls shook. Ceiling tiles rained down. In the pitch black, people dropped to the floor, clutching each other, praying, screaming for help. There was no way to see what was coming. Only the sound, growing and relentless, told them the tornado was here. Survivors later described the feeling: a sudden rush of air, then the world collapsing. One worker remembered being pinned under a water fountain, unable to move, listening to the cries of co-workers trapped nearby. Another recalled the sharp metallic taste of blood and dust, the suffocating weight of debris, and the sense of being buried alive. The tornado ripped the roof away, flattened steel beams, and left the factory a ruin. More than 50 people died that night across western Kentucky. In Mayfield, the tornado's path was invisible. No warning lights, no glimpse of the funnel, only terror in total darkness. For those who lived, the memory is not of what they saw, but what they heard and felt. The monster passing through, unseen and unstoppable. In a world where darkness multiplies the risk, survival hinges on more than instinct. Today, over 60% of tornado deaths happen at night. Proof that what we cannot see can still find us. Technology issues the warnings, but only action saves lives. The greatest danger is not the storm itself. It is trusting your eyes when you should trust the science. Stay alert even when the world goes dark.